Okay, number 1, it says given f of x equals 3 minus 5x minus 2x squared, perform the indicated function evaluations. So in function notation, whatever is inside the parentheses gets put in for x in our function. So f of 4 would be 3 minus, and instead of 5x, it'll be 5 times 4 minus 2 times 4 squared. And then we're just going to evaluate what this gives us. 5 times 4 is 20. 4 squared is 16 times 2 is 32. Why? There. Okay. Then we do 3 minus 20 minus 32. That gives us negative 49. And that is our answer for number 1. Well, for number 1A. 1B is f of 0. So we're plugging in 0 for x. So we have 3 minus 5 times 0 minus 2 times 0 squared. So we have 3 minus 5 times 0 is 0. 0 squared is 0 times 2 is 0. So our answer for 1B is 3. Part C, f of negative 3. We're plugging in negative 3 for x. So 3 minus 5 times negative 3 minus 2 times negative 3 squared. So we have 3, negative 5 times negative 3 is positive 15. Then we have negative 3 squared, which is a positive 9, times negative 2 is negative 18. 3 plus 15 minus 18 is 0. Answer for number 1C is 0. Okay, parts D, E, and F become a little bit more complicated. Part D, f of 6 minus t, we're plugging in 6 minus t everywhere that there's an x in the function. So 3 minus 5, and instead of x, we're plugging in 6 minus t, minus 2 times 6 minus t squared. Okay, so we get 3. Get rid of this set of parentheses by distributing the negative 5. Negative 5 times 6 is negative 30. Negative 5 times negative t is positive 5t. Now, on this next part, before we can distribute this negative 2, we need to take care of the 6 minus t squared. 6 minus t squared is the same as 6 minus t times 6 minus t. So I'm going to use this area over here to do some scratch work. 6 times 6 is 36. 6 times negative t is negative 6t. Negative t times 6 is negative 6t. And negative t times negative t is positive t squared. Combine like terms, we get 36 minus 12t plus t squared. So this is what we're distributing that negative 2 to. So if we do that, we distribute the negative 2 to all three terms. We get negative 72 plus 24t minus 2t squared. All right, all that's left to do is to combine like terms, and we like to start with the highest exponent. So t squared is our highest exponent. We just have negative 2t squared. All the terms with just t, that's 5t plus 24t, so we get plus 29t. And then all the rest of the terms that don't have a t, we've got 3 minus 30 minus 72. That gives us negative 99. And that is our answer for part D. Part E, I'm going to go ahead and start below just because I know I didn't leave enough room there for you guys. Sorry about that. F of 7 minus 4x, we're plugging in 7 minus 4x everywhere there is an x in our function. So this one will be similar to the one that we just did. So distribute the negative 5 to get rid of this set of parentheses. We get 3 minus 35 plus 20x. Then before we can distribute the negative 2, we need to do 7 minus 4x squared. So I'm going to do that off to the side again. 7 minus 4x squared is 7 minus 4x times 7 minus 4x. So when we multiply here, we get 49 minus 28x minus 28x plus 16x squared. Combine like terms, and we get 49 negative 28 minus 28 is negative 56x plus 16x squared. So this is what we are distributing the negative 2 to. So when we distribute the negative 2, we get minus 98 plus 112x minus 32x squared. Okay, then combine like terms and write this in the correct order. We get negative 32x squared plus 132x minus 130. That's our answer for 1E. Part F, we've got f of x plus h. So anywhere there's an x, we're plugging in x plus h. Distribute this negative 5, we get 3 minus 5x minus 5h. Before we can distribute the negative 2, we need to take care of the x plus h squared. So I'm going to use some space to do some scratch work again. X times x is x squared. X times h is just hx. H times x is just hx. And h times h is h squared. If you have these written in a different order, like xh, that's fine too. Just when you write a term that has more than one variable, we usually write the variables in alphabetical order. That's also going to help you realize that these are like terms because they have the same variables and the same exponents on those variables. So when we combine like terms, we get x squared plus 2hx plus h squared. All right, so this is what we are distributing -2 to. So we get -2x squared minus 4hx minus 2h squared. Okay, so combine like terms. And because we have two variables in this, we're not going to try to write it in the correct order. And actually, there's not like terms to combine. Because for terms to be like terms, they have to have the same variables and the same exponents on those variables. So there's not another term that has just x. There's not another term that has just h. This is the only x squared term. This is the only term that has h and x. And this is the only h squared term. So this is our answer for part F. And we're not going to worry about the order on that one. Okay, for numbers 2 through 4, it says the difference quotient of a function f of x is defined as f of x plus h minus f of x over h. So for numbers 2 through 4, compute the difference quotient of the given function. So we're using this as a formula for numbers 2 through 4. On number 2, we have f of x equals 4x minus 9. So if we use this formula, we need f of x plus h. Well, f of x plus h, we did that in part F. We know we just replace x with x plus h. So that's 4 times x plus h minus 9. So we can distribute that 4 and get 4x plus 4h minus 9. So now we have f of x and we have f of x plus h. We can plug those into this formula. So f of x plus h, we just found that. It's 4x plus 4h minus 9. Then we're subtracting f of x. Be careful here. We're subtracting the entire function, so we need to use parentheses. F of x is just 4x minus 9. So this part is our f of x plus h. Then we've got minus f of x over h. To get rid of these parentheses in the numerator, we need to distribute the negative. So we get 4x plus 4h minus 9 minus 4x plus 9. All of that over h. Now if we combine like terms in the numerator, we've got 4x minus 4x, that's 0. And we have -9 plus 9, that's 0. So that just leaves us with 4h in the numerator over h. Now, since all there is multiplication happening in the numerator, there's no addition or subtraction anymore. And because both this term and this term have an h divided by h is just 1. So really all we're left with is 4. And that is our answer for number 2. Okay, number 3. I'm going to skip this part here. I'm just going to go straight to plugging it into the formula. So on number 3, we've got f of x equals 6 minus x squared. So using our formula, f of x plus h would be 6 minus x plus h squared. That's f of x plus h. Now we're subtracting the entire function f of x, which is just 6 minus x squared. So don't forget to put that in parentheses. All of that over h. Okay, let's take care of x plus h squared. That is the same as x plus h times x plus h. And we actually did that in part 1f. X plus h times x plus h is this right here, x squared plus 2hx plus h squared. So rather than do that work again, I'm just going to use that. So we've got 6 minus x squared plus 2hx plus h squared. Minus 6 minus x squared, all of that over h. Now we can get rid of all these parentheses by distributing the minus sign that's in front of both of them. So we get 6 minus x squared minus 2hx minus h squared minus 6 plus x squared. All of that over h. Okay, let's combine terms in the numerator. We've got 6 minus 6, that's 0. We've got negative x squared plus x squared, that is 0. And that's all. So we've been left with negative 2hx minus h squared over h. Okay, there's a couple different ways you could go from here. Because all 3 of these terms have an h in them, or because every term in the numerator has an h, when we divide by h, it just cancels out one of those h's. It cancels out the h here, it cancels out one of these 2 in this h squared with the h in the denominator. So that leaves us with negative 2x minus h. So the other way that you could have gone from this step right here is by seeing that because there's an h in both of these terms in the numerator, you could factor an h out, and that leaves you with negative 2x minus h. And that is still over h. Then you could see that this h will cancel out with the h in the denominator and just leave you with negative 2x minus h. Either way, you end up with the same answer. So either way is fine. Okay, let's look at number 4. We've got f of x equals 1 over z plus 2. Oh, well, this should be f of z. You shouldn't have 2 different variables here. Sorry, either change this to f of z or change the z in this function to x. Either way is fine. I think I ended up using the z, so I'll change that to f of z. Okay, so using our formula, f of x plus h, or in this case, f of z plus h, f of z plus h for number 4 is 1 over z plus h plus 2. minus f of x, or f of z in this case, which is 1 over z plus 2. All of that over h. Okay, in the numerator, in order to subtract these two fractions, they need to have the same denominator. So to make these fractions have the same denominator, we need to multiply by the least common denominator. So let me use some of this space to do some scratch work. Least common denominator is just a combination of these two denominators, z plus h plus 2 times z plus 2. So in order to make these fractions have that denominator, we're going to have to multiply these fractions by something. So for example, the first fraction, 1 over z plus h plus 2, in order to make this denominator look like this, we need to multiply by z plus 2. And if we multiply by z plus 2 in the denominator, we also have to multiply by that in the numerator. So really, we're just multiplying this fraction by 1, because anything over itself equals 1. So we're not actually changing the value of this fraction, but we are going to change the way that it looks. So when you multiply fractions, you just multiply straight across. 1 times z plus 2 is z plus 2. And now our denominator is z plus h plus 2 times z plus 2. Now for the second fraction, 1 over z plus 2, in order for this denominator to look like our least common denominator, we need to multiply by z plus h plus 2. And if we multiply by that in the denominator, we have to multiply that by that in the numerator as well. So we get z plus h plus 2 over our least common denominator, z plus h plus 2 times z plus 2. Okay, we've changed the way that these fractions look. Let's go ahead and change them in our problem. So this first fraction is now z plus 2 over z plus h plus 2 times z plus 2 minus our second fraction, z plus h plus 2, over that same denominator, all of that is still over h. Now that these two fractions in the numerator have the same denominator, we can subtract them. So when we subtract those fractions, the denominator stays the same and we subtract the numerators. So we've got z plus 2 minus this entire numerator, z plus h plus 2. So we need to put that in parentheses because we're subtracting the whole thing. That is still over the same denominator, z plus h plus 2 times z plus 2. And all of that is still over h. Okay, let's distribute this minus sign. So we get z plus 2 minus z minus h minus 2. Everything else is going to stay the same for now. Combine some like terms here. We've got z minus z is 0, and 2 minus 2 is 0. So that just leaves us with negative h over that same denominator. Now, at this point, when we're dividing by h here, that's the same as multiplying by 1 over h. It's the same as dividing by 2 is the same as multiplying by 1/2. Dividing by 3 is the same as multiplying by 1/3. You can, anytime you're dividing by something, you can change division to multiplication and then just flip whatever's in the denominator. So right now it's just h. When we change to multiplication, we'll flip it so that it's 1 over h. You can do that with any number. Or if you were dividing by a fraction, you would flip the fraction when you change to multiplication. So we're going to do that. Our numerator stays the same, negative h over z plus h plus 2 times z plus 2. But we're changing this division to multiplication. And instead of h, now we have 1 over h. Okay, so what's going to happen when we multiply straight across? After we multiply straight across, what's going to happen is this h and this h will divide out. So we can cancel those out, and we're left with negative 1 over z plus h plus 2 times z plus 2. And that is our answer for number 4. Okay, let's see if we can at least get through numbers 5, 6, and 7. For numbers 5, 6, and 7, it says determine all the roots of the given equations. Roots, zeros, there's several different names for these. All it means is we want to know where this function has a y value of 0. So basically your x-intercepts is what we're looking for. In order to find that, all you have to do is take the function and set it equal to 0. So x to the 5th minus 4x to the 4th minus 32x cubed, we're setting that equal to 0. Now we're going to try factoring. If we look at these terms and see if they have any factors in common, x to the 5th, x to the 4th, x cubed. So all three of these terms at least have x cubed. So we should be able to factor out an x cubed. When we factor out x cubed, what we're left with is x squared minus 4x minus 32. Now what's inside this parentheses is a quadratic equation. So the way that you factor a quadratic equation is into two sets of parentheses. This first term, x squared, when you take the square root, that's what goes in the front of both of these sets of parentheses. The square root of x squared is just x. All right. So then what goes in the back of both the sets of these parentheses is a number that multiplies to be negative 32 and adds to be negative 4. So factors of 32 that add to be 4 would be negative 8 and positive 4. Because negative 8 times 4 is negative 32. negative 8 plus 4 is negative 4. Once we have this factored as much as we can, then we set each factor equal to 0 separately and solve. So right now we have three factors. We have x cubed. So we're set x cubed equal to 0. We have x minus 8 equals 0. And x plus 4 equals 0. Because in order for these three terms to multiply to equal 0, at least one of the terms has to equal 0. Now we just solve each one of these equations separately. So to get x by itself here, we have x cubed. We'll take the cube root of both sides. The cube root and this exponent of 3 cancel and leave us with x. And the cube root of 0 is 0. To solve here, we add 8 to both sides to get x equals 8. Subtract 4 from both sides, we get x equals negative 4. These are our roots. Roots, zeros, whatever you want to call them, x-intercepts. Okay, on number 6, we have to use the quadratic formula to find the roots. In order to use the quadratic formula, this function needs to be in the correct order. We need negative 2t squared first, then negative 3t plus 18. Okay, if you don't remember the quadratic formula, we get x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And a, b, and c are these numbers. So in this case, we've got a equals negative 2, b equals negative 3, and c equals 18. So we plug those numbers into this formula. We get t equals the opposite of b, so instead of negative 3, we've got positive 3, plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is negative 2, times c, which is 18. All of that is over 2a, so 2 times negative 2. Okay, now we're going to just do this math. 3 plus or minus the square root. We've got negative 3 squared, which is a positive 9. Then we've got negative 4 times negative 2 times 18. That gives us a positive 144 over 2 times negative 2, which is negative 4. Okay, 3 plus or minus the square root. 9 plus 144 is 153 over negative 4. When you put the square root of 153 in your calculator, you do not get a nice whole number. You get a decimal. So we're going to leave it like this for now. And we're going to split this into two equations using this plus or minus symbol. So that plus or minus symbol really means we actually have 3 plus the square root of 153 over negative 4. And we have t equals 3 minus the square root of 153 over negative 4. When you put these in your calculator, we get t equals approximately negative 3.842. And in this one, t equals approximately 2.3 4, 2. Those are our roots for number 6. Number 7, x to the 4th plus 6x squared minus 27. We're going to set that equal to 0. And we can factor this straight into 2 sets of parentheses the same way we would with a quadratic, like we did in number 5 with this quadratic function. So what went in the first set of parentheses was the square root of the first term. In number 7, our first term is x to the 4th. So the square root of x to the 4th is x squared. That's what goes in the front of both sets of parentheses. We factor the rest of this the same way that we would a quadratic. We're looking for 2 numbers that multiply to be negative 27 and add to be 6. That's going to be a plus 9 and a minus 3. If you want to check and make sure that you've done this part correctly, start with your 2 sets of parentheses and use FOIL to multiply these back out and make sure that you end up with the function you started with. So x squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. 9 times x squared is positive 9x squared. And positive 9 times negative 3 is negative 27. Combine like terms and we get x to the 4th plus 6x squared minus 27. So we did factor correctly. Now that we have our 2 sets of parentheses, we can set each one equal to 0 separately and solve. So x squared plus 9 equals 0, and x squared minus 3 equals 0. Solve for x. So subtract 9 from both sides here. We get x squared equals negative 9. Take the square root of both sides to get x by itself. And what happens here is that we're trying to take a square root of a negative number. So this is not going to work. This will not be one of our roots. You probably could have told that even in this step, because you can't take a number and square it and end up with a negative. So having x squared equals 9 should have told us that we could stop. This is not going to be one of our roots. Okay, on this side, we need to add 3 to both sides to get x squared equals 3. Take the square root of both sides. Get x equals plus or minus square root of 3. You could get a decimal for the square root of 3 if you wanted to, but we're not going to worry about that. We're just going to leave it as the square root of 3. And don't forget, when you take the square root of a positive number, your answer is the positive and negative of that square root.